Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. And we're tying it all together here in this last video. This is self-quiz 4, and we're going to be focusing on hyperbolas. All right? Now, conic sections, and just a quick review here, conic sections come in 4 forms. There's parabolas, circles, ellipses, and now finally hyperbolas. Now, hyperbolas are 2 curves that actually kind of point towards each other, and they're related to parabolas actually, except in a vertical slice of these cones here, you're going to end up with 2 parabola-shaped objects with some space in between. Now, there's a standard form of a hyperbola equation, which we're going to talk about right now, and I went over this in detail in a previous video, so take a look at that. But it's in this bottom equation here. This is the standard form of a hyperbola. The h and the k values here are going to be where the center of the hyperbola is. Now the center is this right here, and it's in the space between the 2 vertexes of the 2 curves of the hyperbola. The a and the b values actually define how far apart those vertexes are. That's the a direction, all right, on the in the x distance, and then the b distance is this part here. Now, the a and the b together form the dimensions of this. I call it sort of a cushion here, but it's a rectangle or a square. And the reason why you need to know that is because now you draw these diagonal asymptotes here from one corner of this rectangle to the other. And the asymptotes are where from the vertex the hyperbola points approach. Now, it goes forever. This is an infinite relationship here, but the curve, which I didn't really draw very well here, but the curve approaches the asymptotes in all 4 of those directions, but never ever touch the asymptotes. So the asymptotes act as sort of a borderline, okay? And it kind of helps define the shape of the hyperbola. So when you look at an equation of a hyperbola, you pick out the h and the k values to find the center, and then from there you pick out the a and the b values to define this rectangle, which gives you your asymptotes. All right. Now in this self-quiz, I'm going to challenge you by showing you a graph of hyperbola, and you're going to work backwards and try to come up with the equation. All right, here are 2 that I want you to try. Look at number 9 and 10. And figure out all the information from the graph and see if you can come up with the standard form of the equation. Hit pause and give that a try. All right, the very first thing we need to do is find the center. Now the center is pretty easy to find. Make sure it's equidistant between the 2 vertexes here of these parabola curves. And it's going to be, it looks like it's going to be -2, 0. All right, now in our equation here, it's going to be x take away -2 inside those parentheses. Okay, that's my h value, and that's why we rewrite it as x plus 2. And if y is 0, that's why it's just y squared. You could even write it this way, but it's the same thing to write y squared. All right, now let's change colors here. And then we do the a and the b values. So 9 is 3 squared and 25 is 5 squared, which means that the a value must be hopefully 3. Yep, if you look at it, we've got 3 going in both directions horizontally, and you've got 5 going both directions up and down. And that gives me the dimensions of my, whoops, put my arrowhead there in the wrong spot. It's going to be 5 up and down, so you have a rectangle and you draw your asymptotes, and there you go. All right, the curves of the hyperbola actually approach those asymptotes and never touch. All right, let's look at the center for the next one. All right, it looks like it's right at 0, 0. So guess what? You're going to have an x squared and a y squared. There's no h and k values to even worry about there. Okay, and then from there you have your a and your b amounts, which looks like it goes in this direction 4, in this direction 5. Alright, so you're going to have your 4 squared and your 5 squared. Again, the rectangle is defined here. That's the cushion, and the asymptotes are drawn, and there you go. So that's the equation of that hyperbola. Fairly simple, and I hope this has helped you review the concepts. All right, thanks for watching this video and the video series. Share it with other people if you think it's helpful, and write your comments. Thank you. Bye. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard and take care.